Hello, good evening all. Am I audible to all of you?
Yes, sir. Good evening, sir.
So I think I have seen just four members in this class. Why? I think Tekla class is going on there, right? Something. Probably some members attended Tekla class. Till now, I have seen just four number of participants, excluding me. Okay, fine. Okay, fine. Let's go with that. Okay. Fine. Good evening, one and all. In the last class, we have seen how to find wind coefficients and how to find wind pressure according to ASC 710. And before the last class, we have seen according to IS codes. Okay, so let's go with Stat Pro basics in this session. Before going to the Stat Pro basics, I think I have all of you people have some knowledge about the Stat Pro, but I'm going into the deep. That's why I am just explaining the basics of Stat Pro in this session, and we'll see a beam, how to do a steel beam analysis in the Stat Pro, and we'll get into the deep. Fine. Let me share my screen once. Yes, okay, fine. Are you able to see my screen, all of you?
Yes.
Yes.
All right. Thank you very much. Okay. In this session, in these lectures, I'm using Stat Pro Connect Edition because Stat Pro, most of the members are aware of Stat Pro V8i edition. Okay, but in nowadays, that is becoming an older version. Stat Pro Connect edition is going on. So, what is the difference between Stat V8i and Stat Connect edition? Basically, in the Stat V8i, there are two types of licenses: standalone license and advanced Stat license. These two are the licenses which are present in the Stat Pro V8 edition. Basically, when compared to the advanced Stat license, standalone license is somewhat slow. Nothing but engine will be slow. Analysis engine will be slow, so the process will become slow. But in the Stat and Stat Pro Connect edition, they have rectified that only Stat advanced license is available. That's why engine will be somewhat higher speed. Okay, so analysis can be done quickly in the Stat Pro Connect edition, and they are giving some network based licenses, etc. These are the developments in the Stat Pro Connect edition, and they have changed the graphical user interface. Mainly, they have changed the user interface of the particular edition. So before going into that, after you installing the Stat Pro Connect edition, you have to know whether we are using SI units or metric units or something else. So before going to that, you have to just, this is the Stat Pro user interface when you open Stat Pro Connect edition. Okay, so you are seeing that. In this, first of all, you go to configure tab. In that, these are the general options available. Language, which language you want to select, basic units, English units or metric units. English units will be LB, feet, right, like that. So metric units generally we follow. So that's why I have used metric units. Metric units nothing but for force it will be kilonewtons, and for length or any dimension it will be in meters. Okay, so generally we follow global y-axis up. Okay, x is generally horizontal, y will be vertical, and z will be perpendicular to the plane. Like that we follow generally. So that's why I have to use all these things. You can see all these options. Save auxiliary data in case any suppose if your stat file is corrupted, if you want to recover like that, this data will be useful. By creating report, you want to create a Bentley logo. Generally Bentley logo will be there, no? So you want to remove that, or you can leave that like that. That is your wish. All these options you can use. Okay, so this is the general user interface. So now I am just creating a new explain basics of you. Just let me take a file name as okay. Fine, I am creating a file. So after creating a file, the new window will be like this. Okay, this is the StatPro Connect edition. Okay, you are seeing a white box in the middle, right? This is the graphical interface. Okay, this can be called as graphical interface. The left side you are seeing analytical modeling, physical modeling, building planner, piping, bridge deck, etc. All these things. This is the workflow tab. Okay, this is the workflow tab, and file, geometry, view, select, specification, loading, analysis, design, and utilities. All these comes under menu bar. Okay, menu bar. In that there are subsections are there. No, if you click geometry, it will be like this. If you view, if you click view tab, this will be like this. All these will be tools. Okay, basically the menu bar and toolbar is different in the StatPro V8 edition, but they have combined in the StatPro Connect edition. This is the one, and you can see number of icons above the user interface in V8 tab. They have divided here with a particular name. Okay, this is and also an advancement. Okay, people who are mostly using V8i, somewhat it will be difficult for some time to use this StatPro Connect edition. So just if you habitate using, then it will become easier for you. Okay, no problem at all. So firstly, let us see step by step what will be. So in the file tab, if you want to create a new file or open a new file, save the current file, save as with another name, or print, etc. All these things you have any Excel sheet or any WordPad, all these things will be there. So no need to explain this tab. So while coming to the geometry, there are certain things you need to know. So these are the grids. Okay, this is the beam grid. If you want to create a beam by using graphical method, this will be useful. Beam grid. So okay, beam grid. If you are seeing these dotted lines, this is the grid. Okay, this is in XY plane. Okay, this is in XY plane because X is the horizontal direction, Y is the vertical direction. Okay, so the grid they have formed is in the XY plane. You just connect these nodes. Okay, so the beams will be formed. Okay, so like this. Okay, these are the beams. So generally, there is one another triangular plate grid is there, no? This triangular plate grid is generally we will not use any plates in our lectures because we are dealing with only framing structures, right? So generally we use beams only. Okay, so beam command only is generally used. This triangular plate grid and quad plate grid, these two are useful while designing slabs, etc. Okay, so this will not be helpful in our lectures. So next, go to the structure wizard. Okay, this structure wizard is nothing but they will have some prototype models in this structure wizard. Suppose if you see here, there are truss models, frame models, surface or plate models, solid models, composite, import something you can import from CAD also here. VBA macro means there are some programming models. Okay, so truss models are nothing but you all know aware of truss, right? Truss is generally it is a like it's like a composite section. Generally, it will have members. Generally, will take compression or tension only. It will not have those members will not take any movement. Like that, a truss will be formed. So there are different types of trusses here: Pratt truss, Warren truss, how bridge, lattice truss, etc. All these things. Okay, frame models. Okay, bay frames, grid frames, etc. All these things: floor grid, continuous beam, cylindrical frame, reverse cylindric, circular beam, all these things. So surface or plate models will be generally for slabs, etc. These are polygonal plate, circular plate, quad plate, etc. All these things. And solid models generally like cubic models, right? Solid block, etc. Composite models nothing but two different sections combined together to form a new section. This is a composite models. For example, bunks or silos generally used in gases and cement factories, etc. Right? All these will be composite models. You can import from any CAD model, or you can program a new model by using graphic coordinating, etc. Okay, like this will be the structural wizard. Structural wizard, in this structural wizard, you will have prototype models. You just directly import the prototype model into our StatPro and you can design with your convenience. Okay, like that structural wizard will be helpful. And for example, sorry, I'm taking off this grid because it is somewhat disturbance for me, right? So am I audible to all of you, right? Clear? My presentation is clear to all of you?
Yes, sir. Yes, sir.
Yeah. So, okay. Now, previously we have seen how to create beams between the nodes by using grid. Okay. So, let us take a coordinated model. Okay. So, you can see right side. Okay. If you go to the geometry here, there will be right side node tab and beam tab here. Okay. In the node tab, there are three coordinates: X, Y, Z. Okay. Any particular point will have a coordinate, right? Nothing but some particular distance from origin. Okay, in X direction, in Y direction, and in Z direction. If you take, suppose if you take a space model. Okay, for beams generally X direction is enough. I'm using only a plane frame, so X and Y directions are enough now. As of now, I'll tell you a space model also. As of now, X and Y directions are enough. So I am using a beam. I'm creating a new beam by using these nodes. Okay, first of all, let us take an origin as a reference point, first point, or nothing but first node. You can take it as origin. Okay, so I'm using X direction as 0, Y as 0, Z as 0. So obviously you can see a black spot here. Okay, a black spot here. This will be called as node. Okay, node is nothing but it is a point. Okay, to create a beam. So okay, one point is created. Okay, so second point. So in order to make a beam, there should be at least 2 points. Of course, yes, of course, we have to make two nodes in order to create a beam. So, okay, I am suppose, let us take my beam span as 5 meters. Okay. Suppose let us take my beam span as 5 meters. You can give X direction as 5 meters like this. Okay. 5. Okay. Y 0, Z 0. Nothing but it is only the beam is in X direction only. There is no projection along Y axis. Okay. So like this, you have to create nodes. Okay. So after that, there are some useful tools you have to know. Okay. So after structure wizard, there is one icon here. You can see one icon. This can be called a translational repeat. So if you closely observe this icon, there are some set time compartments like this. Okay. So how it will work? Translational repeat will be working. Translational repeat is nothing but to create nodes at a particular distance. Okay, nothing but nodes or beams you can create in the same manner. So I'll show you. Suppose this is the node. I'm using a node cursor here. So how to take node cursor, how to take beam cursor, I will tell you in all these things. Okay, so I'm taking a node cursor. So in this stat pro, first of all, you have to know you have there are certain different cursors you have to use. Okay, to select the nodes you have to use node cursor. To select the beams you have to use beam cursor. To select the beams you have to use beam cursor. To select the plates you have to use plate cursor, etc. All these will be different. So to select a node, I'm using node cursor. How this will be taken, I'll let you know. Okay, so first of all, I'm selecting a node. So how translational repeat will work? So first of all, after selecting this node, I'm taking translational repeat command here. Okay, so how you want to repeat this node in X direction or in Y direction or in Z direction? So if I'm taking in X direction, okay, or you can take in Z direction, Y direction, any direction if you want to take. Suppose I have taken in Y direction. Okay, number of steps. How many steps you want to create? Okay, suppose let us take 3 number of steps. Each default step spacing of 5 meters. So if I click OK here, so you can see I have the previous node, this one. So these 3 nodes are created at a distance of 5 meters each. So what is the Y distance here? 0. What is the Y distance here? 5 meters. You can observe right side node tab. Okay, 5 meters. What is the Y distance here from origin? 10 meters. So here 15 meters. Nothing but it has created node at every 5 meters. So these 3 steps. So that's why translational repeat will be useful to repeat any particular node or a beam. Anything you can repeat by using translational repeat command. After that, there is circular repeat option. Okay, circular repeat. So translational repeat is nothing but linearly only, linearly, either in X direction or in Y direction or in Z direction only you can repeat. Circular repeat is nothing but, suppose I'm deleting these nodes to avoid confusion, what I have created. So, okay, suppose this is the node again. I'm using circular repeat, this node for this node. So if I click circular repeat, so it is asking axis of rotation. Either you want to rotate this, you want to create a circular repeat by using axis of rotation using X axis or Y axis or Z direction, Z axis. Suppose I want to create nodes like this, okay, around this, okay, around this. So around this is nothing but, so axis of rotation will be perpendicular to our screen, right? What is the axis perpendicular to our screen? This is the Z axis. Okay, suppose I am taking Z axis here. Okay, so why I have taken, I want to create nodes around this node. Okay, sorry, not around this node. I want to repeat this node in a circular direction. Okay, I want to repeat this node in a circular direction. Okay, like this. So if I want to repeat like this, what is the axis of rotation? This will be perpendicular to our screen, right? So what is the axis perpendicular to our screen? Z axis. That's why I have chosen Z axis here. So through a node, so you have to take center point of the circle for this. Okay, suppose let us take this as the remaining node is there now. I have created 5 meters distance. That one I am taking center node. Okay, that is the node number 2. It has come. Okay, so how many degrees you want to rotate the node? So for suppose I am using complete circle. So complete circle will have 360 degrees, right? So that will have 360 degrees. You can select your wish. Okay, quarter circle is 275, half circle is 180, 3/4 is 275, quarter is 45. You can anything in between them also you can give, no problem at all. Suppose I want to create, let us take 10 steps. Okay, so by using center this node, I want to repeat this node in a circular direction. Okay, circular direction. How many steps you want to create? Suppose 10 steps. If I click OK, you can observe. So this is the center node. All the center node, we have created nodes like this. So 10 steps it has created. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 steps it has created. So this is how circular repeat will work. After this, generate rotate. Okay. So if you observe generate rotate, create geometry from repeating the section once about a specified axis. This is all about nodes, no? If you want to rotate beams, generally this command will be useful. Yet we have not developed any beam here. I will show you. Okay, so let's go to mirror option. So this mirror, suppose I have selected these nodes. Suppose let us take this node. Okay, this center node I have selected. I want to mirror this node. Generally, mirror is nothing but with a specific axis with a specific axis, it can repeat or reflect the other side, right? That will be mirror. Generally, you can understand how the mirror will work. So I am selecting this node. If I click mirror, so you have to, mirror plane will be YZ direction, XZ direction, XY plane. So I want a node to come here at a same particular distance. Okay, so this distance is generally 5 meters. We have seen just, okay, this distance is 5 meters. I want to create this node at same 5 meters distance on either side of this node. Okay, so if I want to create this node on the other side at the same distance, so I have to mirror this one. So for that I have taken mirror option. So mirror plane you have to select. So this will be the line, right? So that line will be in YZ direction. Okay, YZ plane. Okay, so because it is the line, I want a node here. So this should be the mirror. If I want a node, this node I want to be here. Okay, so this should, in between there should be one mirror axis. Okay, so that will be in YZ direction. So I have chosen YZ direction. Okay, so I want to take reference node, this as the reference node, because the mirror plane should be along this node. Okay, this is the reference node I have taken. Okay, move or copy. Move is nothing but this node will get to here. Okay, copy is nothing but this node will be here. A copy will be created here. Okay, move is nothing but this node will be erased here and it will come here. Copy is nothing but it will be here itself and it will create a copy on the other side of the mirror, like that. So I have chosen copy. If I click OK, so another node is created here. So that's how mirror will work. Okay, another one, slab or wall connection. This is not in our scope. Generally, slab or wall connection or for shear walls or any other thing, any RCC structure, you can use this one. Okay, and this next one, input units. Okay, generally I have chosen first one, right? Metric units we have chosen in the configure tab. So this metric units. So metric units, in metric units, length will be in meters, force or load will be in kilonewton. Okay, this is a command. Okay, move node, merge node, renumber nodes. Move node is nothing but I want to move this node to another 5 meters from here. So I have selected this node. If I want to use move node command, move node, okay, how much distance you have to move? So let us take 5 meters. Okay, okay, so this node shifted to another 5 meters from here. Okay, like that move node. Merge nodes is nothing but okay, sorry. This meeting will end in 10 minutes. Okay, I'm just using my credentials. That's why it will be just 40 minutes session, and I'll continue. I'll give another link after 40 minutes. You can join in another class after this 10 minutes out. Okay, don't worry. You'll have full class. Okay, fine. Okay, let us take merge nodes. Merge nodes is nothing but suppose all these nodes. Okay, if okay, if I click these two nodes, okay, merge nodes nothing but which node you want to keep. So otherwise we can delete this node. Otherwise, if you selected these two nodes will be merged. Nothing but only one node will remain. Other node will be gone. Okay, which one you want to keep, either 2 or 6, one node it will keep, another will be deleted. Okay, if you observe, this node have been gone here. So this is move node. Renumber nodes. Okay, renumber nodes. So if you observe, every node will have particular number. Okay, suppose these are the node numbers. Okay, node 1, node 2, node 3, so like that. So if you click any particular node, the node number will appear here. 7th node. Suppose I have selected 7th node. You can observe number 7 here. So if you want to renumber, okay, suppose I want this as a number 15. Okay, so I have selected this node and renumber nodes. It will ask you want to show, yes. So any particular coordinate ascending or descending order you can select. I want this number as 15. So starting from 15, accept. One node is renumbered. So if you select this node, the number is 15 here. So that's how this command works. Okay. And the next one, add beam. Generally, this will be used in our lectures. Okay. So we have to use this command very effectively in our analysis. Okay, so add beam. If you click directly or otherwise, if you click an arrow, if you are seeing an arrow here, okay, so there are some particular midpoint, perpendicular intersection, curved beam, etc. First of all, if you click directly add beam, a beam cursor will activate. A beam creation cursor is activated here. If you observe a cursor with beam symbol. Okay. So if the cursor is like that, you can create or you can join a beam in between any two nodes like this. Okay. So generally don't confuse, guys. In any member between two nodes can be called as the beam in the StatPro only. Okay, generally we use columns and beams for different members, but in the StatPro they don't right. So it does not know what is the beam, what is the column. So that's why it has a beam command only. It does not have column command. Don't confuse. Okay, we have to assign a column property for that. Okay, it does not know anything about beam and column. So all the members joining any two nodes, it will consider as a beam only. Okay, don't confuse between beam and column. All any member connecting two nodes can be called as beam only in StatPro. In StatPro only. Okay. So like that, you can create any member between any two nodes like this. Okay, with this add beam command. So if I want to create a beam at the midpoint of another beam. Okay, so if you select this command, if you observe, this one, it has created a beam, this midpoint, from this midpoint to this midpoint. Okay, so this is our initial beam. This complete one is initial beam, and this is another beam. I have used this midpoint beam command to create a beam between this midpoint and this midpoint. So that's why a new beam created between this midpoint and this midpoint, like that. And perpendicular intersection. So this is a particular perpendicular intersection means, sorry, please select a node first, right? This is the node, and if I want to create a perpendicular to this beam, so if I click this, there will be a beam created exactly perpendicular to the another beam. Okay, like this perpendicular intersection, and curved beam also there. Okay, you can use this curved beam. Okay, fine. Any other question? Someone unmuted, I think. Okay, fine. Okay, so curved beam is a command generally used to create a beam with some particular curvature. Okay, suppose I have to create a curved beam between these two nodes. Okay, suppose I have to create a curved beam, nothing but not like this straight beam, a curved beam. Okay, so if I want to create a curved beam, so you have to use this command. So first of all, you have to select nodes between you want to create a beam. Okay, so it is asking for radius of curvature and gamma angle. So radius of curvature will be known if you draw a particularly curved beam in an AutoCAD. Suppose let us take a radius of curvature is 100
Sir, I have a question about curve beam. Sir, when we design the curve beam, it do not perform in 4 curve beam.
Sorry?
When we design the curve beam in a Stat Pro.
No, it will not design. Generally, any code will not design directly curved beam.
Okay.
Okay. I am showing a feature here. Okay. I want to tell you a point here. Stat Pro will not design or will not perform analysis for a curved beam. Okay. You cannot give property also for a curved beam. Thus, it is in a programming mode only. Okay. You cannot analyze a particular curved beam using AISC or IS codes. Okay. But I'm just showing a reference here. Okay. But if you most of you members will get doubt. Generally, sir, we have curved structures, right? Curved dome structures on the outside. So how they will be created? So you have to take curvature beam like this. After this, you have to create nodes by using insert node command here. If you click insert node, if you select this node, insert node command, if you create a node, sorry.
We can take the axis from AutoCAD, then we can add the node in a Stat Pro, right?
Yeah, of course. I've told you already, you can import any structure from the AutoCAD. Okay. So that is all about geometry you are asking, right? So if you want to create a curved structure, practically, theoretically it is not possible, but you have to take nodes along this curvature and you have to delete this curved beam. You have to join these nodes with a straight beam option. Okay, along the curvature, what nodes you have created, you have to join all these nodes with the straight beams and you have to analyze the structure. That's how they'll do practically. Okay, so probably my session will end up here. Okay, I'll share you another link so that you'll join again. Probably we will not have this problem on tomorrow. Okay, license just got activated. It is in the just practical mode. Okay, so we'll not have this problem on tomorrow. But I'm using personal credential. That's why this problem has happened. So it will stop here. I'll share you the link again. You can join.
After
Okay, nothing fear.
after after how much time, sir?
No, this will end up here. I think so. It is less than 1 minute. It will stop here.
Okay.
Okay,
Next.
fine. Okay, fine. Am I audible to all of you? Right? Hello.
Yes, sir. Yes, sir.
Yes, fine, fine. Thank you. So this is all about creating beams. So the next one, beam layout command, generally it will eliminate, it shows, it highlights the particular beams only. If you have given any supports or any releases, what are the releases, I will tell you. So all these things it will eliminate and it will show you beam layout only. Since I have not supports any releases here, it will not work in this as of now. Okay, so insert node is a particular command if you want to create a particular node in a particular beam. So I have taken insert node option. So if you click any beam with this option, so it will ask, okay, it will ask at how much distance you want to create a node. Okay, before going to that, you have to know start point and end points of the beam first, because it will take a particular distance from the start point of the beam. So how to know the start point and end point of a beam? So there is one command. Just a minute. Fine. So okay. Okay, if you so if you want to know what is the start point of a beam, what is the end point of a beam, so there is some particular shortcut is there, keyboard shortcut. Okay, that is command shift plus E. So shift plus E. So you are seeing this one, right? So there are some particular colors. Every beam will have two colors. One is green and one is blue. So what is this green color and what is this blue color? So green color will indicate start point of the beam. Blue color will indicate end point of the particular beam. So if you take this beam, left side of this beam is a starting point, right side of this beam is an end point. Okay, so like that you have to differentiate. So now you have to, if you want to use insert node on this beam, so it will ask how much distance you want to create. So suppose let us take 2 meters. Okay, nothing but if you give 2 meters here, it will create a node 2 meters from the starting point of the beam. So suppose add new point. Suppose let us take okay. It has created 2 meters from there. Okay, so if you see, this beam will have 2 meters. Okay, if you double click the beam properties will appear. So it shows the length of 2 meters, right? That's how insert command will work. Okay, insert command will work. So now there is stretch beam option. So stretch beam option is nothing but suppose okay, fine. If I want to stretch this beam up to this beam, okay, nothing but I want to intersect this beam with this beam. So at that point of time, I have to use stretch beam option. First of all, which beam you want to extend. So I think all of you have some particular knowledge about AutoCAD, right? You have all of you know stretch command. So what is the stretch command? Stretch command will lengthen the beam, right? Stretch command, oh sorry, will lengthen anything. Nothing but if you want to shorten one thing or if you want to lengthen one thing, you have to use stretch command in the AutoCAD. The similar fashion you have to use stretch command here. So if you want to elongate this beam up to this beam, or if you want to lengthen this beam up to this beam, so you have to use stretch command. So first of all, which beam you have to stretch, that have to be selected, and click stretch beam option. So you can see a dialog box like this. Okay, so you have selected 14th number. Okay, so next it is asking to a point. Nothing but you have to give coordinates. If you want to stretch this beam to a particular node, you have to give coordinates of that node. Okay, or through a distance is nothing but if you want to stretch beam to a particular distance. Okay, you have to use this, or to an existing node. If you have a node here, okay, you beam your beam. If you want to beam connect to this node, so you can select that node. Otherwise, to an existing member, there are 4 options. To a point is nothing but you have to give coordinates. Through a distance is nothing but you have to give distance. To an existing node is nothing but you have to select the particular node up to which the beam has to be lengthened. And to an existing member, okay, suppose I want this beam to intersect this beam, or up to this beam it has to come. I want this. Okay, so how to do that? So here there is a cursor option there, no? So you have to select that cursor and you have to select this beam. So if you apply like that, so if you see this beam has come up to this beam, so it has divided this beam into 2 parts and it has intersected. That's how stretch beam will work. Okay, and these are all about connecting beams. Okay, so suppose suppose I'm deleting all these things. It has getting clumsy, right? I'm deleting all these things. Okay, so I'm creating again a fresh set of nodes 0 and 5. Okay, so okay, if you see bottom left corner, coordinate representation is there, nothing but UCS icons. Okay, universal coordinate system is there now. Horizontal is representing x-axis. This is generally by default. StatPro will show you an isometric view. Okay, that's why x, y, and z are with some inclined direction. So this can be changed in the view tab. Okay, if you go to view tab, if you see front view, so x will be in horizontal direction, y will be in z direction. That's how you have to change first. Okay, so I have created 2 nodes. One is at origin and second one is at 5 meters x distance from the origin. So that's how I have created 2 nodes. So I want to explain the remaining commands here. Okay, suppose I have to use this connect beam option. Okay, so this is the small icon you are seeing here. This is the connect beam option. So for that you have to select nodes first. Okay, you have to connect beams between any nodes, right? So first you have to select those 2 nodes and then you have to select, I'm selecting these 2 nodes and I'm using this option to connect a beam along x-axis because these 2 nodes are like this in x direction only. So if I want to connect a beam between these nodes, it has to be in x direction only, right? So that's why I'm using this command in x-axis. So you can see a pop-up with 1 members are created. Okay, so the node, the beam is automatically created. So you can add that in 2 ways. You can add a beam by using add beam command, or you can add beam by a connect beam command. So like that you can create Okay. And the other thing, if I have created a node, suppose x something 2.5 x distance. Okay, y is at something. Let us take 3 meters, and other thing 2.5, and y is at something. I'm just trying some with some relevant data. Just don't confuse. Okay, 5 meters. So I have created these nodes now. So if I want to connect beams, these nodes with a Y beam, so first I have to select these nodes with the node cursor and then go to connect beam option with Y axis. You have created a member. So the next is nothing but move beams option. Move beams is nothing but if you want to move this beam to a particular distance, you can use this option. Okay, but there is some shortcut. Okay, in any move command, you can use F2 option. Okay, F2. Okay, functional key is there. I think everyone know about functional keys, F1, F2, F3, F4, all these things. You'll get it in your keyboard. So F2 is the shortcut key used to move any beam or any node. Okay. So like what we have seen in move node option, there is one move beam option. So if you want to move this beam to a particular X distance, you can use this option, move beam. So I want to use just 2 meters. So, okay, it has moved to 2 meters from here. Okay, previously I have given X distance 2.5. I have just moved to 2 meters. It will become 4.5. That's how move beam command works. Okay, and then intersecting these beams. Okay, intersecting beams command. If this beam is passing through this beam, okay, so you have to intersect these two beams. Suppose so for intersecting beams, the nodes how it will look like, I'll tell you. Okay, suppose if any two beams are like this, so entire length is showing as one beam and this entire length is showing other beam. So if you want these two beams to intersect, so you have to use that command. So you have to select two beams first and you have to select intersect, highlight selecting beams or intersect selected beams. Okay, so if you want to highlight them or if you want to intersect them, highlight is nothing but just it will show, it will not intersect. Okay, it will show just. And if you select intersect selected beams, so what is the tolerance limit? Nothing but 0.001 meter, nothing but 1 mm. If these distance are just, suppose if you are seeing with naked eye, okay, just these beams are like this. But if it has some particular z direction, okay, suppose this beam is in the forward direction and this beam in some backward direction, you cannot observe with naked eye because you are seeing just xy plane. But if there is some particular just z distance, okay, you cannot observe in this view, right? So that limit can be called as tolerance limit. Intersect selected beams z distance. If these two are separated by z distance of z directional distance of 1 mm, it can be connected. Or if you don't want any tolerance limit, just these two at 0 level, if you click OK, okay, two new beams created. If you see here, a particular node is created. Okay, so by intersecting these two as separate beams, so the fresh set of two new beams are created and a particular node is created at the intersection point. That's how all these things. Can it be higher? No. Okay, fine. So that is all about intersect.
Sorry to interrupt you.
Yeah.
Your picture is showing on the screen. It will create problem in recorded session when we do watch after recording.
Sorry.
Your picture is showing on the screen right side.
No.
Yeah.
I have no. I have not included my video here. No, I'm not the participant. Someone is okay. Srinivas Yaram. He's the one. Yes.
Okay, now it is
Now
removed.
Srinivas Yaram. Who is that guy? Okay, fine. He has now closed now. Right.
Yes, sir. Yes, sir.
Fine. Thank you. Okay. Fine. Okay. And the remaining one. Okay. So this is all about, right? So, and then merge beams, merge selected beams option. If these two, suppose, if you don't have these two beams, okay, suppose I'm deleting this one. Okay. So if you see here, okay, first of all, you have to know beam numbers command, shift B. There are some shortcuts in the Stat Pro. You just have to know. Okay, as I already told you, shift E is for shift E. Okay, shift E is for starting and ending point, to know the starting and ending point of a particular beam. Just shift E like that. Okay, green color is at a starting point, blue color is the ending point. And as you all know, Control C, Control V, copy and paste options. No, right? I think everyone everyone have computer knowledge in these days. So everyone knows about this. Control C, copy, Control V, paste. This option also works in Stat. Okay, you can copy any beam or you can paste any beam at a particular distance. Okay, that command also work here. And shift N is nothing but this is a command to show the node numbers. Shift N. If you click shift N here, it is showing the node numbers, right? If you see here, this is the node 1, this is the node 5, this is the node 2. This is the shift numbers, shift N. Okay, this command will be for nodal numbers. Okay, and shift B. The next one is shift B, beam numbers. Okay, shift N is for node numbers, shift B is for beam numbers. Okay, if you want to see the beam numbers, you can click shift plus B. Okay, if you want to hide it again, if you click shift plus B, they'll get hide. Okay, shift B. And F2 command is to move. Okay, move any particular beam or move any particular node or move any particular plate. Generally, we will not use plate here. Just I'm telling you, any component you can move with a command of shortcut key of F2, functional key. Okay, and shift R, shift S for supports, shift M for materials, shift A for property, shift R for reference. All these things. If you want them, I'll give you shortcuts. All these things. Okay, I'll provide a text for you. All these things. In between, while I'm using these commands, I'll let you know where I'm using all these things. Okay. So now, okay, suppose I'm clicking just shift B, it is showing beam numbers here, 1 and 3. Okay, since these two are collinear beams, I want to create a single beam only. I don't want this beam here. Okay, I want a single beam from here up to here. Okay, but it has two beams because a node is separating in between them. But I want to join these two beams. So generally, all of you know about join command, right? In AutoCAD, it will have join, JOIN, join command. So like that, it will merge beams. Okay. Okay. So I want to select these two beams first. And if you click merge beams option, it will ask. So it will show here. What are the beams you are merging? 1 and 3 you are merging. Beam number. If you want to keep beam number 1 or beam number 3, So anything you want. So I'm selecting beam 1. If you have given any profile, it will show here. I did not give any section profile or any section property here. So that's why all these are blank. Okay. So if you want to keep any other profile, you can select here. Okay. In these two profiles, because I did not give any profile till now. That's why all these are blank. Okay. But it is showing beam numbers. Okay. What number you have to keep? You have to name it as beam 3 or you have to name it as beam 1. That one you can select and merge option. If you see the node gone here and these two beams have merged to a single beam. This is how a merge beam command works. Okay, renumber beams. So we have seen renumber nodes command here, right? So like that, in the same fashion only, in the same fashion only renumber beams work. Suppose there are some particular just I'm using a command Control C, Control V before that. Okay, just I want to create this node at a particular distance, copy node, Control C. I have selected one node and Control C. I want to create this, I want to paste this node at a particular distance. I'm using Control V. Just it is pop-upping a dialog box at what distance you have to create. Just I want 3 meters of X distance from this. So it has created. I have used this beam. So like this. So I have created this node to explain you the number of nodes. Suppose these numbers have the beam numbers are here 1 and 2 here if you see. So I want this beam number as 4, this beam number as 5. Okay. So to do that, you have to select both these beams and go to renumber beams option. So which criteria you want to follow? X coordinate, ascending or descending. Ascending or descending is nothing but you have to X moving from left to right or right to left. Okay, so that is ascending order. So I want to rename the beams from, suppose let us take beam number 4. If I click accept, these two beam numbers are numbered in ascending order 4 and 5. If you click descending order, this will get 4 and 3. Okay, like that. And these are about rename. Next, break the beams. Okay, suppose if you have a particular node here, suppose this beam, how much? This beam 5 meters. Suppose I have node at 3 meters. Okay. So I have node at some particular 3 meters here. So if you click this beam, it is selecting from this point to this point, but I have node here. If I want to break the beam, so if I select this beam, if I create, you have to select a node first. If you select a node, if you create, if you click this command, break beams, okay, so it has divided into separate beams, right? Like that, this command will work. Add plate, add solid, all these things will not be in our scope. Okay, just I'm going to view tab. In that view tab, label settings. Label settings is nothing but node numbers, node points. Node points is nothing but shift K. Okay, suppose in anything. Okay, so you are seeing just beams here, right? You did not have information about where the node is located. Can you observe here? There is no node here. There is no node. You cannot observe with naked eye. Just there are nodes here, but you cannot observe with naked eye. So if you want to see a node, so that is just for shift K. Okay, shift K is the command to see the nodes. Where are the nodes? Okay, shift K. So that is all about. All these things can be you can label it: node numbers, node point, support dimension, all these things. Okay, just all these are basic values. Okay, all these we have some particular shortcuts, all these things. Okay, this is all about label settings, and no need of explain this, because generally instead of all these things we use shortcut commands. Okay, I'll tell you where I'm using. Okay, suppose display zoom window is nothing but if you click zoom window here, if you select this part will get zoomed, nothing but if you while using camera, how the zoom option will work like that only. If you click zoom here, if you click this thing, the point will zoom out, zoom in. Okay, or display whole structure means if you click display whole structure, the entire structure will get displayed. Okay, because in the previous step you have zoomed in, right? If you click display whole structure, again it is reset to the default view. Okay, default view is nothing but isometric view. Generally start default view is isometric view. Okay, so it will get reset to the isometric view default if you click display whole structure command, and then zoom in, zoom out, all these options. Okay, all these options, if you do 3D structure, these will be helpful. Okay, and here you get different types of views: isometric view and top view, bottom view, side view, left view, front view, right side view, back view, all these things. How generally in the AutoCAD also like this we have, right? So like that, all these things. If you want to see the structure from the top, nothing but if you want to see the node plan in a 3D structure, so you can go to top view. Okay, top view. If you see the top, it will be like this. Since it is a 2D structure, you cannot observe much difference. But if you go to a 3D structure, you can observe why it is showing all these things. Okay, if you want to rotate a structure in at a particular axis, if you want all these things, rotation, etc., scales, tables. These tables are nothing but if you want to see design results, all these things will be there. Material section properties, load values, all these things can be seen in a tabular view. That is the option for tables. And 3D rendering is nothing but if you give a particular profile. Suppose if you have given a particular eye section to this, if you click 3D rendering, it will show eye section, nothing but how the actual model looks like. It will show here because I did not give any profile here. It is just if you give any profile, suppose a tube, you have given any tube, or you have given any pipe, or you have given any eye section, it will render. Rendering is nothing but it looks like a practical view, how it look like. Okay, that will show you. That is the rendering. And select. So just in the previous half an hour, I have just told you different types of cursors, right? In the select option, those will be there. Okay, node cursor, beam cursor, plate cursor, solid cursor, all these cursors will be there. If you want to select a node, you have to use node cursor. If you want to select a beam, you have to use beam cursor, etc. For plate cursor, solid cursor, etc. But the default thing will be the beam cursor. In the Stat Pro, the default thing will be beam cursor. Okay, if you want to select a particular node with the beam cursor, it is not possible. Okay, so because if you see here, I'm trying to select this node, it will not be possible with the beam cursor. So you have to select node cursor and then you have to drag so that you can select node like that. So how to select all these things? If you want to select all these geometry, so you can select all, it will all will get selected. Okay, otherwise inverse, suppose I have selected this beam, but I want to select these two beams. Inverse means except this beam, remaining beams will get selected. All these things, all these just a basics, right? So specifications. Next, go to the specifications, database. So this is the main thing. Database is nothing but different types or different country databases will be there. How the Australian database will be there, how the Brazilian database, how the Britain database, how the Canada database. Database is nothing but profiles. Okay, don't confuse about database. Profiles. So what are the Canada profiles? Suppose rolled steel, timber. Suppose if you click rolled steel, so what are the shapes available? HSS round. HSS is nothing but hollow steel section. Okay, HSS round, hollow steel section round. Generally, we can call it as pipe. Okay, hollow steel section, rectangle, okay, tube. These are standard and these are non-standard, and angles, channels, welded shapes, H shapes, M shapes, etc. All these things. Okay. So this is how the database will be. You can see here Indian database also there for hot rolled steel. Okay, generally we see all these things, right? ISMD, ISH, ISMC, ISLC, etc. All these things, right? So all these will be there. I shape, S shape, M shape, W shape, something, okay, T shape, all these things, tubes, pipes, etc. Okay, and this is all about database. Prismatic is nothing but if you want to create a particular database of your own, okay, your database is not there. Suppose you want to create a particular welded section, okay, that is not there in the database. So you can create it by your own. So if you want to create a solid, okay, this is all about solid section. If you see here, circular solid section, rectangular solid section, T sections, trapezoidal sections, okay, all these things. Without section, if you want to create a particular specifications, tapered eye sections, tapered tubular sections, tubular or pipe, anything, round or square or hexagonal, anything you can create by your own. Or otherwise, if you want to assign a particular choice of your own profile, you can use this channel, column, you can use. Okay, so this prismatic command is nothing but the section which does not have in database. If you want to create it your own, this command will be helpful. Okay, so generally this command will be used extensively in our analysis. Okay, prismatic command, because in PEB generally we will not use hot roll sections much. Okay, so we will not use hot roll sections much. That's why we have to use welded sections. Okay, or I can say built up sections. Built up sections are nothing but sections which can be connected by using different plates. Okay, suppose if I want a built up eye section, so you have to take a particular plate for web, you have to take a particular plate for flange. So you have to join these flanges and web with a particular welding. Okay, that it can be formed a welded section or a built up section. So that will not be here. These are all about rolled steel, hot rolled steel and cold formed steel. So our built up sections will not be here. So you have to create it by your own, like by using this prismatic profile. So tapered sections, generally we use tapered sections only. Okay, so because where there is no bending moment, your section can be less, right? Where there is much bending moment, your section should be high. Generally, PEB structures will follow bending moment only. That's why all the PEB structures, you can see most of the PEB structures, not the small structures. You can observe in larger structures, they'll get tapered, okay, according to the bending moment. So by you have to assign the parameter to a particular beams. So this is how this tab will work. And plate thickness, all these things will be for surface plates. Okay, constants. What are the constants? We have Young's modulus. Generally, Young's modulus will be denoted with E, right? Shear modulus, G, Poisson's ratio, mu density, thermal coefficient alpha, damping ratio, all these things. What are the generally all these will be here in the materials. Okay, if you see here, different types of properties: aluminum, concrete, stainless steel, steel 275, steel 355 type, steel 36 KSI, steel 50 KSI. Okay, kilo pound per square inch KSI is nothing but, okay, all these things. Okay, so different types of materials will have different properties. If you want to create your own property, you will have to do this by your own. Okay, this is all about our sections. All these remaining we will not use anyway. You can see here fixed support, pinned support, custom support. Custom support is nothing but fixed butt support. Fixed butt. Okay. So how this fixed support, how this pinned support, how this fixed butt support. Generally, any PEB structure will be any PEB structural design engineer try to design a structure with pinned base only. Okay, because the foundation would be less and you can do tapering for a column. Because why you can do tapering for a column for a pinned base? Suppose if the structure have pinned base, what is the moment at the base of the structure? If since it is a pinned base, pin will not have any moment, right? Moment will be zero at the pinned base. So only lateral forces and shear force will be there. Lateral forces due to wind or irregularities in the structure, and shear due to vertical loads. Okay, or lateral load components, I can say like that. So that's why a PEB structural design engineer must try to design a PEB structure with pinned base only. So in any case, a pinned base structure is not passing in the deflection. Generally, all these pinned base structures will pass for loads, but if it is a high-rise structure, it will not. Sometimes it will not pass in the deflection criteria. Okay, serviceability criteria. You have to go for a fixed base at that portion. And sometimes, if you are designing a particular beams, okay, suppose if you are designing a simply supported beam, generally, what is a simply supported beam? A simply supported beam will have what type of supports a simply supported beam will have? One side it will be a pivot support, one side it will be a roller support. But if you observe, there is no option for roller directly, right? You have fixed here, pinned here, and you have other thing custom here. Custom here, nothing but you have to create your own support. Okay, so pinned support, one side you can give for a simply supported beam. Other side you have to give roller support. So how to create a roller support? So you have to use fixed butt command here. Fixed butt. Fixed butt. What are the releases? Fixed is nothing but only F5. Okay, the vertical component should be there. Remaining everything should be released, right? For a roller support, the Fy should be there. All the other things should be released. Fy is nothing but only vertical component. Remaining all the things should be released. So like that, Fy I have unchecked. Remaining all the items checked for releases. Okay, so Fy is fixed. Remaining all the items, Fx in the horizontal direction X force, in the lateral direction Z force, moment about x-axis, moment about y-axis, moment about z-axis. All these things have released, only Fy is there. Okay, so if I add that support, if I assign to a particular node, so if you see from a front view, okay, so this is the roller support. You can observe only Fy component is there, right? Roller is nothing but only vertical component should be defended. All the things should be released. This is how the roller works. And you can all the things about, you can know all the things about pinned. Pinned connection is nothing but all the lateral forces, X direction, Y direction, and Z direction. All the forces can be taken by a pinned connection. But roller connection only Fy will be taken like that. You have to give all these supports. Okay, so with this I'll stop now. Up to this, you have any doubts? Because the time is going to end. It is less than a minute, so I have to stop here. Fine, I think all these are basic properties, and we'll do analysis in the next session. That is by tomorrow. We'll do analysis of a beam, how the shear force and bending moment will come, and how the deflection will come, and we'll do it by your manual calculation, and it will be checked with stat pro calculation. That's how you'll get an idea how it is behaving. Okay, all these things you'll get to know in the next class. Fine. Everything is clear.